All right, so today I'm turning my computer into not quite an Xbox 360, but something a lot closer to it. We're going for aesthetic, and no Arduino, no coding, literally just wiring, couple transistors, and a DF player. All this stuff is cheap. We do got to 3D print some parts or order them on PCBWay if you don't have a 3D printer. I got all the STL files. I got a wiring diagram, and I got a parts list for you, including all the tools you're gonna need. And I'm not gonna show you how to set up this software part. This is an app called Play Night. They got a bunch of themes for it. Right now, here's an Xbox One theme that I kind of edited. You can find tutorials on YouTube on how to install this. It's pretty simple, pretty easy. If you're shooting for this for your computer, it's just creativity. Work with what you have. For example, I have a cheap ass case and a wonderful wife that'll paint something on the side of it using acrylic paint. So now let's get started on talking about the actual parts. All right, this should give you an idea of what these 3D print files are going to look like. All this is a mount for your button, which is there. It doesn't come with the button. You have to buy an old faceplate for an original Xbox 360 Fat. Cut the rivets off the back. I mean, you could probably model one. I just liked it like this better because I didn't know how to do this clear plastic. You can see that it's on like these springs where they flex. You can see it flexing in there a little bit, an LED. So you can kind of see I got a board back there that's held in by, I have these tiny little holes. I would have made them post, but they're too small. And most nozzles won't be able to print reliable posts that small. So I extruded them in so it's easier to, you can see the holes and it's easier to shove in DuPont connectors, which I used the male end. I clipped it off. I heated it up with my soldering gun and I pressed it in at the same time. I only did 4 posts. I did each corner. Then I soldered it in real quick before it melted more plastic. These posts right here are to hold the button in. You put the clear part first in, because these are 2 separate parts, but they go on the same post. And then you put this part on. Once it's flush, you heat it up with the hot glue gun, you press down, and it's like a rivet. Moving on to this is your actual enclosure for all the parts that are thinking your transistors. That when you press this button, it actually triggers the sound. Here, I'll just do it. Triggers the sound, and then also triggers your computer to turn on. It's not super complicated at all. It's literally the brain is 2 transistors. But this is an example because of the only board size I had to slip into these pegs. Only have 2 of these boards, the other one's in there. First you would solder up your board. I'll make a wiring diagram on how to do it. And this is like one of those DuPont connectors I was talking about. It's it's not clipped all the way. But that's a male end of a DuPont connector. I don't recommend doing it like this because it's really easy to snap. Try not to leave wires hanging or something because eventually they flex like this. And then they're going to come off the solder while you're working on it. You're going to have to resolder, especially when you got a bunch of wires around the same spot. That's a bitch. You're going to want to use a resistor, 2 resistors. You're putting almost like straight 5-volt standby straight into this. So this is kind of like an overload just to protect it. That'll be in the wiring diagram. You don't need to understand it. You just got to put it out in the same order I have it in the wiring diagram. You're going to put this in here. I recommend looms. You should probably see it in the video, but there's these black braided things with like green stripes in it. It just makes it look neater than having all these colored little wires going to everything. And then these drop into these pegs. It's not so tight where you can't put it on. Like, you can put it on pretty easily, but be careful if you don't get it on precisely the first time. You only got 2 pegs in, you can't put in the other one because it's too much at an angle like this. Make sure you make it flat when you pull it back up or you'll break a peg. Screws, self taps. I'll also have them in the parts catalog. Here is the mount for the speaker. You just get some M2 screws and you screw that in. The hole's already there. It's not threaded, but it will thread itself in. It'll be fine. And then this one, I have a small M2 bolt and nut holding the speaker in. It's going to be slightly at an angle because of where the wire is on for the speakers I used, which is what I modeled this hole for, so I recommend you use the same ones. You can see it in my dusty ass case. Here's mine. Here's all my looms coming out of the same hole because I use these connectors, which I'll talk about later, which I wish I didn't, but I did. And there's what the speaker looks like. Here's what the screws look like, holding the lid down. And there is my M2 bolts holding my speaker down. Recommend using a washer. Depends on the tolerances of your 3D print, where the hole might be too big for that M2 bolt head. So just use a washer. What the heck is this USB 3 header doing right here?
I have to get a splitter. Anywhere you can get 5-volt standby or standby 5 volts, which basically means your computer's off, but it's still getting power. So like you can test this by check these USB ports, plug in your phone while the computer's off, not while the power switch is off, but while like this your actual computer's off. Plug in your phone here, see if you got power. If it does, then you can use the same thing I did, maybe make it a little neater. I just didn't want to cut it because everything else right here is getting live. There's getting power. Like there's a couple of 5-volt standby posts right here that's getting power, and I did not want it to short on anything, so I left it on there. I don't want to clip it. I could have just put electrical tape on it. It's fine. Recommend hot gluing any post like that in the back because that is going to have some wire strain, especially once you wire it up, and you do not want those wires coming off of the solder points because I already had it break once. That was a DuPont connector that was all the way through. It broke off while I was testing the button, and so we had to solder it again back on, and then I hot glued the dog shit out of it.
Okay, so I'm going to explain this real quick for y'all because this is my first wiring diagram, so I don't really know how to do it, so we're going to explain it. This is where you're going to get your power, your 5-volt standby, and then you're going to make kind of like a bus or a rail if you want. It's a lot easier if you do, or if you just do it as you go. That's what I did. So make sure these two never touch. This is ground. You'll also get it from the same pin. You're gonna need, I'll show you which 2 pins that is if you're using the same connector as me. Anyways, you're gonna get those. We're gonna assume you already have 2 wires coming in to your computer case or into your box onto your board. This button is not going to be on the board. You're actually going to route a wire out from your 5-volt rail on your board inside of your box, and you're going to route that wire out to your 3D printed kind of thing right here onto the board that's on the back of that. You should have soldered your button to that. I'm not going to do a wiring diagram for that because it's literally just you got your perf board, you put your button on it and you solder it, and then you make the connections on the 2. Then that's going to come back in to your board around right here. And then you're going to want to put a resistor. You want to make a tiny 2-pad rail, make have wires coming out of it or not. You could use the resistor's little wires that comes with it and make that run to those pads. But regardless, you're going to need a resistor here because this is just breaking a hot line. Okay, so we're going to put resistors on each one because this is what's going to trigger the transistor to let this circuit through. Ground, it's a common ground. I tested it on my computer. You can connect these grounds together. It is ground for your power switch. On this diagram, not show. I guess I did do that. If you don't have a multimeter and you cannot confirm that this part of your power switch is ground, do not connect it to common ground over here like I did. Just leave it. Oh shit! Because no, it's not going to work if it's not common ground. Make sure it's common ground, or your thing's not going to work. it just won't turn on the computer. I don't know what it will do, because in order for this transistor to work, it needs this ground, and this ground needs to be the same. It probably is. I don't know if it is or not. So I'm just warning you. You should probably check that out. Each motherboard's different. If you don't know anything about electronics, this is the only part I should explain. Capacitors are going to be wired in a short. If you know a little bit of electricity and that set off some alarm bells, from what I understand, it builds a charge. And once that charge is built, it breaks the line. And basically what you're doing is you're smoothing out the voltage for this speaker. Any little thing will make that speaker pop unless you put that on. For this, the transistors, how this works is when this to this completes a circuit, it also completes the circuit for this, okay, from here to ground. The reason I have to use transistors is because this trigger, I don't know its own voltage. I think it was 3.3, but I just know it's not 5 volts. I just know these two cannot touch or bad things will happen. IO1 and your 3 volts from your power switch should separate systems. We're completing the circuit. We're closing the loop from 5 volt to ground. We're making it short, and that's going to allow the power from the collector to go out to the emitter, which is going to close the loop for the player here, and then close the loop for your computer to turn on, because how your computer turns on is literally just a post. All your button does is short it for a second, and then your computer turns on. So that's all we're doing with these transistors with one press of a button. We're doing both things, and that's literally all this is. So yeah, this is not a power rail. I just didn't know how to model it. So that's that. Or your USB 3 header if you're using the same thing as me. The reason I use the splitter is because I also want to use the USB ports on the front of my case, and so that's why I had to use a splitter. Or else I could have just done something else, a lot simpler. But this way, this works. I recommend it. Your pins are going to look exactly like this, where you're going to have one pin missing right here. The wires I used were the wires going to this V bus, which was which is my source of 5 volt standby, and this is common ground. You're also going to use this ground test if your power switch ground is actually ground. 99% of the time, I'm pretty sure it is, but it's important to check that out. And this might not even work for you. This might not even be standby voltage. So you don't have to take anything off just to make sure it is. Use your USB parts right here. Plug in your phone when your computer's off. And if it starts charging, then you have standby voltage even when your computer's off. So that's what you need. This pin is your voltage. This is your ground. This is going to be 5 volts. And if we come back over here, that's what this source is, and then that's that ground. So you're just going to wire those up. Like I'm going to talk about it later, but I recommend using connectors so all this comes apart and assembles real easily once you're putting it actually in your computer, or if you have to work on it, it's real easy to work on them. I don't care what connectors you use. Basically, anything that's going out of your board, you want to use connectors. So I have small wires for anything going out of my board. This wire's on one connector. It's a 2-pin connector. I don't have any out here, but I also wouldn't recommend the ones I bought. They suck. Do not use DuPont connectors, for the love of God. Do not use these and then just put the male or the female in the male. That shit's not going to work. That shit's going to come apart. Use actual good connectors. Look it up on Amazon or something. Let me see what I had, and I'll pull it up. So these are the connectors that I used. This is what I mean. 2-point actual legitimate connectors. There's not a male and female. They just work like that. Make sure that your blue wire is the same blue side as the blue coming out on that one. That's very important, or you're going to short something. I don't recommend this. This is what I used. It says you don't need to strip it because this little brass part right there is going to cut it. I put it all together and my shit didn't work, and I was freaking out. And I just found out it's because almost none of these connectors were working as they were supposed to. I actually had to strip them. I put a little blob of solder on the end of each wire so it didn't slide back out. But yeah, I'm not satisfied with even how I have it, but it's working. But basically, you just need something that does this job, where I have my connectors going out of. And so these are all small wires I have coming out of my case. They're even shorter than these right here, because I have the connectors all bunched up in here. They have enough where they can stick out and I can disconnect them there and then shove them back in, or even connect them and then shove them in where the connectors are inside this little pocket right here underneath the speaker. That's what I recommend, so you don't have connectors showing in your case. So I have 4 coming out of this slot on mine. One of them is the input voltage of my ground and my 5 volt standby voltage from my USB header. The other one is bringing in the voltage, your power switch that goes to the board. I have a connector in between that, and then I have a connector for the speaker, or no, not for the speaker. Oh yeah, I do have a connector for the speaker because the speaker is mounted to the lid. So if you want to take the lid all the way off without having to desolder anything, I recommend putting a connection there. That actually doesn't leave the case, so that one's really small. Because then I have its own connector for the LED coming out, and then for the switch. Just use some common sense on where you want your connectors to go. Same thing with your loom. I'm not going to tell you all the wires to put in your loom. That should just, like, if it's going to the same spot, use one loom. This red wire is my voltage going in. So that should help you, because on the wiring diagram up here, where it says VCC, it's going to be up here. Yep. Pretty much it. Make it work. Thank you for watching, and send me videos of it working in your PC. I'm going to include in the description links to the wire diagram, some other things that might help, the README, the parts list. Also, almost forgot, you're going to need a hole saw. Here's what it looks like. And you're going to need some wire strippers. Here's what those look like. And a meter I recommend, so you can troubleshoot, because then if something doesn't work, you'll have no idea why. If you need any other parts, I'll include them here. And yep. Again, thank you for watching, and that's it. And don't forget to send me a picture of your setup.